Hi, everyone. Thanks so much for joining SWAN Forum's webinar. We've been very excited to bring this webinar to you, primarily focusing on making the business case for digital twins. And we'll be hearing from Water Corporation in Australia and also PDAM Surya Sembada, the Surabaya city in Indonesia. So we are very excited to bring this webinar to you. And today's agenda, we're looking at the welcoming and SWAN update, gonna give a bit of a background there, and we'll be hearing from 2 digital twin journey presentations, and also Q&A and open discussion will be at the end. So before I give you a bit of an information about SWAN update, I wanted to see who's in the room. So let me just quickly share my screen. We use Mentimeter. So if you could get your phone up, if you're using your phone or if you're on your computer, you can just click on the link that I've just shared on the chat and let me know where you're joining from, which country, which part of the country are you joining from. I'm joining from Mongolia, so it would be great to see who we have in the room. We have, I think, big number from Australia, Malaysia, Singapore, New Zealand, the US. I'm glad. I think this time zone, our planning team was talking about it, where it would go great in terms of timeline. A bit late in the West Coast, but we're looking at it there. Malaysia, Solomon Islands, Thailand. Great to see some folks from the Southeast Asia, Singapore as well. Yep, you can either click on the link that I've shared or you can use the QR code in your phone. We always want to see who is joining us and where they're joining from. Yeah, while you guys are putting in, the next one I wanted to see was what type of organizations do you work for? Where are you in the water ecosystem? Are you a utility, tech provider, academia regulator? And I think this information is always important for us to see, also for our speakers. We have quite a good amount of number from the utilities joining and our solution providers. Thanks, Jeremy. I see it in the chat that you're joining from Malaysia. Hope to see you at the Asia Water. I'm going to share a bit more about the event coming up. But great to see you, Jeremy. I will be coming back to Mentimeter. So if you're holding it on your phone or on your laptop, please do not quit from Mentimeter. I'm going to come back to Mentimeter with some of the following questions, but great to see a number of people joining from different parts of the water ecosystem. So let me just change my screen. Just a moment while I pull it up. Yep, looks good. So really great to see everyone here. Let me just give a bit of a background on SWAN, as some of you might not be familiar. So my name is Sembada and I'm the Asia Pacific lead for SWAN Forum. And SWAN, those who might not be familiar, we are a global nonprofit forum that bringing together water utilities, solution providers, and industry experts, everyone in the water ecosystem to advance the use of smart and data-driven solutions for drinking water, wastewater, and stormwater utilities as they move across different digital maturity levels and in their digital journeys. And SWAN also provides resources and the knowledge base for a global sector that includes standardizations, case studies, reports, and different technical community of practice groups. And SWAN, these are the different resources that are driven by our diverse ecosystem of members who use unbiased platforms to collaboratively work together, engage together to adapt the data-driven solutions. And these are some of the resources that are examples of the recent practical reports. Since we are in a digital twin webinar, you can also go into our SWAN Forum website to see SWAN Digital Twin Maturity Assessment Tool. Also, you can come across DAS report, Data as a Service, and also we recently published Smart Metering Playbook that brings together over 80 different case studies of utilities where they're going in their journey. So would be a great resource to look at. And as SWAN is a global network of regional and global utilities and also water ecosystem, we are bringing together different engagement opportunities to meet and bring the smart water dialogues to different parts of the world. And within Asia Pacific Alliance, just next week we will be at the Asia Water event. We are the lead digital partner at Asia Water, and we're hosting half the event. So if you are in Malaysia and Kuala Lumpur next week on April 8th, or if your colleagues will be around, please have them register into the event. I'm going to put them in the chat, but it'd be great to see it all there. And another event that is coming up with SWAN is we'll be hosting a full day Asia Pacific workshop on June 18 at the Singapore International Water Week. So this is another opportunity to also meet together and engage there. So this is also coming up. And with our global SWAN Forum network, we are hosting our annual conference in Tampa, Florida in June 2nd through 4th. So if you are a SWAN member, you have a free allocated number of free access to come to our event, but we're very much looking forward to this 3 days of conference to talk about smart water all around. And lastly, I would like to share our Americas Alliance team is working on agentic AI workshops project. So we're accepting utility-centered case studies from SWAN members. So if you are working on the agentic AI case studies, it'll be great to hear from you. So I'll put on the chat on how you can share your utility story to be in our agentic AI case studies project by April 20. And without further ado, I want to thank our Digital Twin Working Group Asia Pacific leaders who have been working in the back end to make this webinar possible. This webinar is being co-hosted with our Digital Twin Working Group. As a global group, we were launched in 2019, and we have different groups based on the region and also based on different areas like BEAM and also APAC and Americas and Europe alliances. And with APAC, it is led by David Moore from Watercare, Asem Zabin at the GHD, and our just formerly APAC lead Clarissa Phillips, who just gave her work after the 2 years of completion. So I would like to thank her also for her support. So would like to thank to our 3 co-leaders who have been working on making this webinar possible. And I would like to introduce David Moore, who is a Smart Systems Manager at Watercare and also our SWAN Digital Twin Working Group APAC lead, to take it from here to share a bit more about Digital Twin and also introduce our speakers afterwards. So.
Thank you, Zavo. So just a bit quickly about me. I'm Dave Moore. I'm the Smart Systems Lead at Watercare. Now, Watercare, for those who don't know, is the water and wastewater supplier in Auckland. So we do the complete source to tap to 1.7 million customers, and then the toilet to treatment as well. So we cover every bit. So I've been always be going through a digital journey. So what is the digital twin? I suppose is really the first thing. I'm quite lucky where I work. You can see behind us here our big control room. So hopefully it's a quiet day in Auckland towards the end of the day. nothing will happen, people won't go running about, but we have the big digital twin behind us of our water and wastewater system. We call it our nerve center. So that's just one example. There's other ones most people have and don't realize is the GIS systems we have in the water and wastewater industry is one. The SCADA, as mentioned, network models. Other ones then start bringing the data together and get more and more complex, which is where we can start to do some very, very clever stuff. So we're also building a digital twin of our sewer systems. Lots of sensors out the network, AI analyzing to help us. Got some very, very good case studies here today. Been talking to the presenters and very interested. We have massive pipeline project over in Australia and then some energy. Very topical at the moment, energy optimization with the prices going up over in Indonesia. So as we said, the digital twin can be many different things. Now, all of us here are have to answer to our shareholders, accountants and everything. So one of the things is, how do we make it stack up? Because we can build things. Are we building it for the sake of things? Is there a reason we're doing it? A lot of it is to optimize, prolong life, reduce costs. So I always get asked in my business cases, well, what are you going to save us? And some of it is just go in the air and thumb stuff. Others, we can do basis. So smart metering's an easy one for me. I can say, oh yeah, the telecoms costs are half the price of what the metering is. Very easy to stack up. Others get a little bit vague. How much energy we save by this optimization, how much in chemicals. So we've got a couple of very good case studies, and what we really want from this is to share with you, give you some ideas. Let the presenters share what went well, what didn't go well with their journey. How can we help you build your business case? So we have Arvin and Palupi. Arvin's over in Watercare in Western Australia, and Palupi's in works for PDAM in Indonesia. So how I'll do this, I'll introduce Arvin first, and we'll run through his presentation, take a couple of questions, and then we'll introduce Palupi and run through her presentation with an open Q&A at the end, hosted by my colleague, Asem. So firstly, on Arvin, we have two speakers here.
Oh, quick one, Dave. Would you
Yeah.
like to go over the three questions we had before we move on? To see the digital
Let's
twin.
have a look. I didn't see. Let's go through here.
Yeah, would you like to? Yeah, I think like we had the. Just a quick one.
Yes. So it's really just on the Mentimeter. I mean, what is the biggest challenge in getting started or progressing with digital twins? I mean, I know if I suffer from what is the clear use case, and it's just really good to hear how others are suffering from this. You know, what's the business value? I can get funding easily if I can define what I need to do. So it's just good to see what others are pain points or challenges are across the industry. So I'll give this 30-40 seconds to run. Okay, so it seems to be that biggest challenge is certainly it's the same one I suffer from, which is the clear use cases. Data quality, I mean, that's a very good one as well. I mean, we always say here at Watercare, we're data rich, information poor. It's what do we do with it? It's not just the quality. It's we've sometimes got so much, it's really how do we serve it up to make things. The skills and capability is how do we get all the teams working together? So hopefully from the case studies, we can learn a bit of it. Silos is a favourite one. Everybody does retreat in the businesses. It's very, very hard with the especially in the water industry, with the cross-functional teams. We have our guys, or my team's very operational focused, but how do we work with our digital and financial colleagues and bring this to fruition? And this age-old challenge of budget and funding. Now, hopefully, if we can walk you through how these two examples are done, it'll give you some ideas. So I'll now launched into, oh, sorry, the second one is, where do you see the biggest opportunity to apply? Where's the biggest value in your industry, do you see? So we'll give this a few seconds for people to go through this. Yeah, so looking at the results, certainly what I see is the first three I always see is going very, very hand in hand. The asset management, when do we repair things? How do we run things? The optimization, we need to make everything run really, really well. And we certainly do have it here. We call it the burning platform. Is as people come out of the business, we've had a lot of people. We had one guy retired yesterday at 87 years with us. So it's all that information leaves the business. So it's how do we bring some of this support into the new start? So certainly the operational decision support is definitely a way we're going to move in Watercare with the data-driven stuff. So it's good people are certainly seeing the things. So one of this, or the next slide, please, Salbu, is we'd also like to canvass you. This is absolutely a fantastic webinar for us because this is one of the first ones we've managed. We picked the times that worked for most people across the region, a bit late in the day for me. And we also thought, let's go cross regions because we can potentially pick up the West Coast and India as well. So it'd be really, really good if people could fill this in and then play it back to us. What would you like to see covered in future calls and webinars on the digital twin? Because we've got an absolute wealth of members, wealth of case studies across the whole geography. So there's an awful lot we can learn from one another here. So if people would just put their ideas down, it'd be fantastic. And then we can help plan the future with us. Okay, right. I jumped the gun a bit earlier, so I'll start with the introductions now. So the first presentation we have is from Arvin from the Watercare over in Western Australia. Now, I had the privilege to see this in November, this presentation, and I thought this is just the scale of this is absolutely mind-blowing on the 600-700 kilometer pipeline. I mean, I've built some big pipelines, but nothing like that. So just the control on that is huge. I mean, that's almost a tenth the size of Watercare's network in one pipeline. So that's just to put it in perspective. So, and it's also Arvin's from the Watercare. It's also with SUEZ as well, who've provided the smarts on the control. So there's been a partnership between the two. So first off, I'll introduce Arvin as the speaker. So Arvin Seeva is a project leader who brings together engineering, automation, and people. With over 20 years in the energy and water sectors, he specializes in control systems and the smart use of AI to make utilities more efficient and resilient. At Water Corporation in Western Australia, Arvin leads a talented team delivering digital and automation upgrades that keep one of the world's largest water utilities running safely and sustainably. The geographic area of this utility is absolutely just mind-blowing, how big Western Australia is when you look at it on a map. So there's not many that size. His journey from control systems engineering to leading large-scale transformation projects reflects his passion using technology to empower people and create real impact. Having worked across Europe, Asia, the Middle East, and Australia, Arvin believes the future of water lies in blending data, design, and human insight. I couldn't agree more. That's something that I'm very interested in. He continues to drive innovation that improves how communities live and how we take care of the planet we share. So his co-presenter as well, if he's turned his camera on, much smaller bio he's given me, is Evan's the head of digital for SUEZ and ANZ, and he leads the SUEZ team to develop digital twins and other digital solutions across water infrastructure. So I'll hand it over to Arvin and Evan to take this from here.
Good morning, all. Thank you, David, for this kind words. I'll share my screen. If you guys could let me know if you're seeing what I'm seeing. All good. Arvin, can you see my screen as well?
Yeah, looking good, Arvin.
Very good. Thank you. Good morning, all. Selamat pagi. And I'm Arvin Siva from Western Australia. I'm with Water Corporation. And today I also have Arvin with me. We are excited to share our journey in terms of implementing a digital twin. Before I begin, I would like to begin this webinar by acknowledging the traditional custodians on the land which we are meeting on, or which I'm presenting from, which is the Wajak people of Nunga Abuja, and their continuing connection to the land, water, and community. I pay my respects to all members of this community and their culture, and to elders past and present. So we will try to keep this webinar as exciting and brief. We'll talk about the who's in the room. We'll give you the backstory for the Gauss pipeline. David stole my thunder there by explaining how huge this project was or is, and it's what it means to us. The whys, the hows, the whens, key important things are the lessons learned, the why nots, what we should not be looking at doing, or what we're happy to share with, and the success story behind all of this, the wins that we've got out of it. So I am Arvin Siva. I'm the team lead for project delivery here in Water Corporation. My background is in control systems and automation, and obviously now I'm in the project management space. Spent about a good 20 years of that in a blend of oil and gas, and also now in water. With me, I have Arvin. Arvin, would you like to say a few words?
Yeah, thanks, Arvin. Yeah, Evan Atkinson, as David said, head of digital for SUEZ. So my experience has been in deploying this kind of digital twin and analytics tools across water infrastructure projects. So looking forward, let's get into it.
Very good, thank you. So a bit of story, what happened? So as David alluded to, Western Australia is a very big geography. So in the 1900s, we were having remote communities in a place called Kalgoorlie, which is about 500 kilometers east of Perth, and water was a big issue, right? We had people tankering water, and there was no pipeline, there was no reliable water. So the government of the day decided to endorse a project, which was to supply water from Perth to Kalgoorlie, which is about covering up to 560 kilometers. Now, over time, if you think about it, trying to build a pipeline this long in 1903, to be fair, there's no Power BI, no Primavera, and they still did an amazing job. They went through the geography of it, and they've successfully delivered a pipeline that was able to service the communities. Now, along this pipeline, there is about 27 pumping stations, 89 pumps. There's 31 tanks on the main conduit itself. At present, we pump around 90 megaliters of water across the pipeline. It feeds off our agriculture land. It feeds off the mining customers. They need water for their activities as well. And ultimately, it feeds the community in Kalgoorlie as well. Along the line, we have about 100,000 customers and major mines and farmlands. Right before 5 years ago, to manage this pipeline was a big issue, right? It required a team of about 200 operators. We were running 3 shifts, 8 hours each. We were having people to start pumps, stop pumps, start open valves, and all in almost in a manual sort of orchestra, right? We were struggling a lot. It was a very complex pipeline. As some of you or all of you would know, pipes do break, and when pipes break, that's change management, and how do we react to it was a big issue. Alongside in Western Australia, we were competing for electricity, and therefore electricity cost was going up as well. So our operational cost was going up based on how we were operating the pipeline. We are also, in a good way, we are having a population boom. We are seeing a lot of people migrating into Australia, and that also grows water demand as well. And therefore, as the water utility, we had an obligation to make sure that everybody had enough water. David talked about the 2.9 million kilometer square. That is true. We are the largest water utility by geography, not by size, but it brings a lot of challenges to us. Because of this this long pipeline, we had different alarms. We were flooded with alarms. And And it was creating a stress to our operational team. Like imagine you rock up at work and the first thing you see is 10,000 alarms. It's mind-blowing. And how do you respond? How do you react and all that? And what was a true alarm against a false alarm? The mental load on our operator was high. We had high operator turnaround. Every time somebody new joins in, we have to train them up, bring them up to speed. And by the time they get normalized in the business, they get too stressed about doing the work and they leave. And that was a repeat cycle we were facing. And we need good people at the end of the day. And it's very hard to find good people to do the work we are trying to do. So a couple of years before, a few years ago, we then sat down with SUEZ, our technology partner, and we had a discovery mode. We went with a few technology partners, but obviously SUEZ was the one that we preferred the most, and they came up with a solution. Now I'll hand this slide over to Arvin to talk about what the solution is. Arvin.
I'll get that one. Thanks, Arvin. So as you said, the solution selected was Aquavant's water supply. And what we set about was a combined project team of how do we configure this decision support automation tool to deliver the outcomes that were desired for the gauze pipeline. So ultimately what this solution does is anticipate and predict demand along the pipeline, all the different offtakes, the supply zones which are supplied. We have a model there, a predictive model to anticipate how much water is going to be required when. Along with that, we take in direct current set points and storages across the network from the control system. And those are combined into a real-time mathematical model. So what's generated is a forward-looking schedule for all of the assets along the pipeline to schedule when those pumps are going to be supplying, when water is going to be moved from stage to stage, anticipating when water is going to be taken out and to meet the demands. And that is generated every 30 minutes. So every 30 minutes, they get a new forward-looking schedule of how the pipeline is going to be operated. And then to close the loop, that forward-looking schedule is then delivered into the control system and automated. So the pipeline is actually controlled according to those schedules that are generated. And then every half an hour, that solution is updated to take account of the current operating conditions. And obviously this is an important engineering task. It's not something you want to just deploy off the shelf. There's a lot of considerations around data security, around reliability of the pipeline, around safety of controls. And so we set about a common engineering team between SUEZ experts and the Watercorp team to understand all the contact points and build a robust design so that we could go all the way from advisory into real-time control. And if we jump to the next one, I just thought we might share what the end result looks like at the end of this process is obviously a user interface. So this is what the operators eventually interact with. And so what this is again, a forward-looking. So you have a series of graphs in the middle, and everything to the right-hand side of that orange line is a forward-looking projection of what's going to happen at this particular portion of the network. So you've got a reservoir profile at the top is how the reservoir is going to be kept within its operating constraints through the supply of water of pump stations feeding into this reservoir and then supplying out of that reservoir along the pipeline according to the schedule, which is the bottom. We call them our donuts, or that's the forward-looking schedule, half hour by half hour for each asset. And that results in the middle graph, which is the flow profile, which is going to be coming out of the pump station. And so the users can interact with what's going to happen in the future, what's currently happening right now, run what if scenarios as well around certain outages or maintenance planning. So it becomes their forward-looking way of managing what's going to happen in the network to take people out of SCADA and looking more into what's going to happen going forward. I'll hand back to you, Arvin.
Thank you, Arvin. Now, the next slide, we'll talk about the key milestones here. But I think just to touch a few points what Arvin was saying just now, it's not out-of-the-box solution that we chose, right? There's many different flavors of AI today. You've got agentic AI, you've got generative AI. What we were comfortable to work with SUEZ was a machine learning, supervised machine learning, right? So SUEZ came with all the experiences in the world and all the different models that we could look at. And then we sat down with them and we tested our data set and stuff. So the first year, in 2022, it was a proof of concept. So we had a zone, we segregated the pipeline into 6 zones, and we took zone 3 and we trialed it out. It was small enough, but complex enough for us to try it out. And we went through every single item that we could think of, and it was good to have SUEZ on board, and they were sharing their knowledge from the other customers. We had a visit to Hunter Water, although the two models are different, but it was understanding their journey and their issues and concerns that we could then bring on board onto our project. Now, although we call it a trial, by the time Zone 3 piece of work was finished, it was operational. So we were able to see the full life cycle of a project. And really, by the time Zone 3 finished, we started to see the benefits of the project. We started to see savings in terms of energy cost. And the rest of those 3 years, 22, 23, 24, 25, was pretty much hyperscaling the job, so getting into all the other zones. Now, during the proof of concept, we addressed all that. When we scaled up the job, we also took on the lessons learned, what didn't work for us from on the ground, what didn't work for us from the coding standpoint, and we worked on that. We had a full engineering. Heads-up was important because this is the first time we were trying to implement an autonomous control onto our systems. So a lot of us were quite new to this as well. So we had to bring in experts and start talking about what could go wrong. So it was not a traditional heads-up, if you like. And then moving on, we also then had to plan for developing the commissioning plan. As you see, we've had 80 odd different stations and various different sites that we had to visit and upgrade. And that controlled upgrade allowed us to have a scaled implementation. So every time we implemented a zone, we could test it, we could see how the two zones interact together, and then move to the next zone. And finally, in 2025, we could have a full system upgrade. Once the full system was upgraded, we also had to do disaster modeling as well, in case everything goes down, how do we respond to it? And then once all that was done, we called it as project completion. Arvin, anything to add on to this one?
Yeah, thanks. I'll just add what I thought worked really well out of this delivery methodology, and something that people could apply going forward, was that pilot in Zone 3 of that one particular part of the network really helped because it was end-to-end. It wasn't a theoretical simulation. We deployed on that network and understood what are the ins and outs of actually real-time control, collecting data, implementing, exposing it to operators, getting feedback on what worked, what needed improvement, what was unexpected, because there's a difference between knowing a project is coming and then actually interacting with the system and providing that feedback loop. It was really useful and smoothed the process through the expansions as we went forward, because everyone had that practical experience and actually knew what it was that was coming. And so issues were identified earlier, and we refined the methodology all the way through the rest of the project. And that really set us up for success. So I think it's a good methodology for people to follow.
Thanks. Okay. Now, the lessons learned and what we're happy to share. I think what really went well was the collaboration between Watercorp and SUEZ. When we selected SUEZ to come onto this journey, I think we had a few different potential vendors that we could work with. But at that point, SUEZ had maturity of the technology that we were comfortable to work with. And we didn't want to go absolutely, with a blank canvas approach. We wanted a technology provider that had the confidence and track record to show us what worked. And that collaboration worked very well. We were very transparent in the whole project. It was not like a client vendor sort of relationship. It was true partnership. It was a single team. Then we were upfront that our data quality was not great, and they helped us to work through it in terms of what we can do with the data and all that good stuff. We had lots of assumptions that we challenged during the project, that some of them were true, some of them were not true. One of the key important things was responsive, not reactive. Changes happen in a project all the time. Now, this was a brand new project in terms of a mindset and everything else. We needed to respond to issues, not react to it. It was very easy to just say, oh, it's all gone bad and finger pointing. But it was good to see both SUEZ and Water Corporation teams to actually work together to figure out, okay, what can we do? How do we respond to this? We needed that perseverance to help us push this project through. Otherwise, it would have been a very, very difficult project to complete. We had the right people, skills, and motivation on the team. Now, this is key, because sometimes we might have the brightest minds in the world in the room, but we needed the right motivation. We needed people to believe that this was the right approach, that having this layer of AI would help the water corporation as a whole. We wanted people to be troubleshooters, not fault finders. So we had we had some good engineers that were constantly saying, oh, no, this is wrong, that is wrong, but not able to offer a solution. We had to understand and realize, okay, the team setup was important, that we wanted people to solve problems, not just finding problems. Our engagement with Hunter Water through SUEZ was good. I think that helped us understand and paint the picture. End of the day, it is a very unknown project. So in 2022, we really didn't know what we were getting into. So having a chat with Hunter Water helped us understand, okay, things we need to think about, things where we needed to put the investment in, things where we needed to increase effort and time in as well. What could have been better? Data and documentation. I think it's great to see the Mentimeter earlier on, and a lot of that correlates to what we've been going through as well. Like, we have drawings, but what the drawing says in the system and what's on site is two different things. So we understood that, to deliver projects, we had to be better ourselves in terms of data quality and all that. To allow time to develop, right? Like, somebody can tell you an AI project can take 2 weeks, but always allow the time. And it is important for us to allow the time, because that's where we invest in due diligence. This is not a cookie cutter project. This is not a rinse and repeat project. This is new. So we need to allow the engineers the time to test and validate the system. And once that works, we will be in a better space to make it operate our pipeline. Clear communication within projects and larger audience is what Arvin was saying as well, that stakeholder engagement was a key issue as well. It's a new project, trying to frame it up, trying to get people to think differently as well, trying to ask people to tell us what else we should be thinking about. So that communication is key. We all assume, oh, it's a project and everybody knows what we're doing. That was one of the key lessons learned. The last one, it's a good problem to have, maybe. It's potential technology dependency, right? So right now, we are finding operators are starting to trust the system too much because it works. But there will come a day when we lose comms to all sides and we need manual control. So we want to make sure the operators are not 100% dependent of the technology. It's no different from a pilot today, working on an Airbus or anything. They always still, they can autopilot a landing and a takeoff, but they always have to do it manually every 10th flight or 8th flight, I remember. Similar approach we have over here. We want the operators to still manually operate a system as and when required, to make sure they still know how to operate it when we do need them to operate it. Arvin, anything to share on to this as well?
I think you captured that really well, Arvin. The only thing I'd add is, having done a few of these projects consistently, what could be done better, invariably people say more change management. So bringing the business along through the process, understanding who's going to be impacted, and including them in the journey early, so they're not handed a finished solution, but they have ownership of it through it, universally comes up. And equally, learning from others who have done it, that connection to Hunter Water in this case, but people who have already been through the process always sets up the project well.
Thank you. And our final slide, success to celebrate. So we've delivered a project safely. It worked very quickly. We start seeing the cost savings, and we are on target to recover ROI within the 3 years. This is way ahead from what we originally expected in the business case. The team was also recognized by AWA in Western Australia, and we won the award for Best Regional Infrastructure Project. There's intangible benefit as well, things that we can't put a number on. We are seeing better operational team. So the EES survey is our employee engagement survey, and we are seeing our operators are feeling better at the role they're doing. They're feeling a bit more confident. They're feeling that the stresses are lesser due to, or the fatigues are lesser due to manually operating the pipeline. And there are further other intangible success stories, I suppose. I mean, the way that we now operate the pipeline is much more leaner and slicker. So we hope to see less wear and tear with our pumps and valves and everything else. We hope to see that we can expand our water supply more effectively and efficiently as well. Arvin, anything else to add on this one?
I'd just say it was a really enjoyable project to be on from the whole team. The way Watercorp approached it meant that we did have that one team approach, which made, when the inevitable challenges came, we were set up to knock them over. And I'd just add that this is not a finish line. This kind of optimization or digital twin is an ongoing journey. The network will change, the needs will change. And so we really set up an ongoing relationship to maintain that the solution and ensure that those benefits are maintained through the lifetime of the solution. So, yep, looking forward to what comes next.
Good. Thank you. And I think that's the end of my presentation. I'll stop sharing screen just now.
Thank you, Arvin. That was very, very good, Arvin and Evan. Just if anybody's got a couple of questions, my colleague Asem will lead a couple of questions to break this up a little. Is there any? So I've just got one here, which is, or a couple here. What helps decide if AI is the right solution to any challenges for the water utilities? And the second part, which leads into that, is what helped make collaboration successful between public-private sector on AI projects?
All right, I'll
throw it over to you two to answer that.
Absolutely. Like I'll take the first one, I suppose. Is AI the solution? Right now, everybody thinks AI is this silver bullet for everything, right? And a lot of us just have ChatGPT Pro account, everything, we got AI. That's not the case. We have to look at the use case. So we have two different pipelines here. So this pipeline is highly complex, highly critical. It made a lot of sense to invest the effort, time, and money to get AI or supervised machine learning to help us operate this pipeline effectively. We have another pipeline, and that only has one pump station. For us to use this level of AI onto it is a major overkill. We'll spend more money maintaining the AI than the pipe. So it has to be, you have to understand what the technology can do. We have to understand what we want to achieve and make that decision as a team. Evan?
Yeah, absolutely. I'd just add to that and say, look, AI is one of the tools. You have to think of it as a tool belt. What's the right tool for the job? So rather than looking for what AI can do, I'd say, what are the challenges you have in the business and what are the best tools to address those challenges? If AI is the right tool or this kind of decision support is the way to go, then great. But as you said, you don't want to put it in just because it's the latest thing. You want to make sure you've got the right tool for the job.
Absolutely. Now, David, I think the second question is about how do we make public sector, private sector relationship work? Yeah. So I think in this instance, because it was a new journey for us, we were very transparent with SUEZ, and SUEZ came along and proved that they had a track record. In this instance, we developed that one team approach, right? And it's not just by saying it's one team, it's how we work, the commercial agreements, everything else was reflective of that. So we knew things that we know where SUEZ was actually spending a lot of time and effort, we compensated them for that. And there are parts where SUEZ is saying, actually, Watercom doesn't know this. Let me spend some time with you guys and give you the training and understanding so you know what we're talking about. So there was that give and take for both sides that made it work for us. And I thought that was helpful. Evan?
Yeah, I would just separate ones where there's an existing solution to a known problem, and then you want to learn on the experience of what's been done before and adopt the best model. The second case is where you're exploring a new space. If you're doing something more exploratory and looking for a collaboration, then I would look to set up and follow more of an agile methodology and start with the use case of what problem you're trying to solve, and then do an experimental approach of, okay, how does AI work? Does it support it? And iterate based on success, which is very different to deploy an existing solution. So I think you want to take a different approach depending on whether it's a known or a new space.
Okay, right. We'll come back to questions after the next presentation again. So I see there's a couple popped in the chat. We'll pick those up at the end. So just before I introduce the next presentation, if people do have questions, if they could just put in which presentation in the chat the questions for. So let's do a quick introduction. Just bear with me a moment. So over to Palupi now. So as we said earlier, we'll move north now to Indonesia, and Palupi works for PDAM, and she has a bachelor degree in environmental engineering from the ITS Surabaya Institute of Technology, class 2003, and this was followed up by a master's in water resource management at the Indiana University of or School of Public and Environmental Affairs, class 2001. She's working for the, excuse my pronunciation here, Perumda Minum Sia Sembada Surabaya and Surabaya Water Supply since 2005. So I'll hand you over now for another very interesting presentation. Over to you. Can't hear your microphone's off, Palupi, if you're on mute.
Hello, hello everyone. Good morning. I will share my presentation. Okay. Do you all see my presentation?
Yes, maybe just go back to the first slide. I think we can see the thank you. Yeah.
Okay. Okay, hello everyone. I'm Palupi from Surya Sembada Water Utility. I'm glad to see you in this webinar to share the implementation of digital twin in Surya Sembada, Surabaya. It's about Surya Sembada Surabaya. Surya Sembada Surabaya is a water supply government-owned company. We serve more than 3 million population in Surabaya City, Indonesia. We have production capacity in 2 water treatment plants in Ngagel and Karangpilang with total more than 12,000 liters per second. In the distribution system, we have more than 6,000 kilometers of pipelines, 3 distribution centers, and 20 booster pump stations. People in Surya Sembada, Surabaya, we have 1 CEO, 1 director of service, 1 director of operation, and 1 director of finance, with 652 permanent employees and 814 non-permanent employees. About financial performance, per 2025, the total asset is about 113 million US dollar. The revenue each year is about 70 million US dollar, and the profit each year is about 16.3 million US dollar. That is slide about Surya Sembada Surabaya. So why Surya Sembada try to implement IoT-based technology? We will have some areas to be implemented in Surya Sembada. It's about energy efficiency, non-revenue water, and also support system. For the energy efficiency, we have digital transformation and automation, SCADA system in production and distribution, energy consumption monitoring system, quality monitoring, automation in chemical dosing, and automation in booster pump station. For the non-revenue water, we install sensors to read flow and pressures throughout distribution system. And we have geographic information system. For the support system, we have BI application and also personal assistance. We encounter some challenges in the implementation of digital transformation using IoT-based technology. Those challenges are budget limitation for investment. The second is capacity to operate and maintenance and sustainability. The third is areas of development, procurement and legal aspect, instrument security, and integration with existing system. The capacity to operate and maintenance is a big issue because we have low capacity in operation and maintenance of digital twin or IT system because we are lack of IT person, and our assets are scattered throughout the city, and the instrument's accuracy is not reliable. We have tested some flow sensors, and the display data are inconsistent. About the procurement and legal aspect, it's about the procurement method and also qualification and requirements for tender, because all instruments that should be that will be installed should be labeled SNI or Indonesian National Standard. But most of instruments for IoT still don't have SNI. And should have permit for telecommunications instruments from Ministry of Telecommunication. About instrument security, we should consider instrument protections that will be installed in roads or public area from any potential damage and theft. Integration with existing system is about application, tools, machines, instruments. Most vendors offer exclusive system that is incompatible with our existing system. We move to next slides. Okay, now let me tell you about the journey of digital twin implementation from 2021 to 2025. In 2021, we established Digital Control and Instrument Department. We design areas to be implemented of digital twin. In 2022, we synchronize and develop information system like GIS, hydraulic modeling, SCADA, operation system, business intelligence. And also we did a pilot project for online pressure transmitter. In 2023, we did automation of kandangan booster pump, installation of 222 pressure monitoring system, and installation of 58 flow monitoring system. In 2024, we did automation of Made and Kedung Cowek booster pump, installation of 212 pressure monitoring system. In 2025, we make improvement of SCADA in production and distribution system, improvement of smart pumping station in Keputih, and also energy monitoring system and predictive maintenance system. The most influence factor in digital transformation in Surya Sembada is the commitment of management that is derived into 5M: man, machine, material, method, and money. Unfortunately, we have a strong commitment from the management. Okay, lesson learned, what went well. We have a pilot or small project to analyze effectiveness, efficiency, and its feasibility to be implemented in larger scale. A pilot project allows us to pinpoint any problems, design the suitable methods, and collaborate with existing system. We don't have any courage to directly make a large scale project due to we have many restriction. And at the first, we thought that we will buy all the instruments, install, operate, and maintenance by ourselves. However, this method didn't work for us, so we choose data as a service contract. So we buy data from vendors, or we call it DAS. DAS allows us to be more efficient in investment budget, operation and maintenance expenditure, and we have no worries of instrument security. However, the issues should be resolved are data accuracy and frequency. So we set up service level agreement in the contract. What could be better? Digital transformation in a company brings technical, operational, and social impacts. So to align this policy better throughout all lines, it should be stated in business plan and disseminated to all staffs to make all lines are engaged and minimize misunderstanding. And digital transformation will achieve the final target by dividing it into several stages, which considers two organizational needs and capacity. And this is the picture of automation in Kandangan pump station. We have some benefits. They are improving service by water pressures improvement, efficiency in human resource because it is unmanned, and also efficiency in energy consumption. We can see from the graph here that the pressure in distribution system after automation is increased and relatively stable. And it is a picture of automation in Kandangan pump station for energy consumption. After automation, the energy consumption dropped significantly. So it is efficiency of bill payment for electricity is about 36 to 40%. It is the picture of SCADA in water treatment plants. One of our water treatment plants in Ngakeltri. The benefits are improving service by controlled operation and reliability, efficiency in human resource, performance of operation assets controlled by the system, efficiency in energy consumption, efficiency in chemical consumption, and fast response of quality water, raw water anomaly. Bill payment for electricity in Ngakeltri reduced more than 15% after utilizing SCADA. It is the picture of energy monitoring in head office. We can see that bill payment for electricity reduced more than 13% by using digital monitoring for energy. And it is the picture of IoT for NRW reduction. We have DAS. The data is in the left. We have DAS contract to acquire flow and pressure data of water supply from water treatment plants and also water in pipelines. And We have also GIS and hydraulic modeling. The data from DAS updated in a GIS and also hydraulic modeling. So the benefits is we have monitored flow and pressures for identifying leakage and to make a more responsive decision. It is a success story for IoT implementation, especially for service improvement. In 2021, we still have many areas with low pressure, and we cannot control the situation at that moment. And after we implement IoT for service in a pipeline, we can see in 2023, 2024 until 2025, the pressure throughout the distribution system become better. We have installed 434 pressure sensor in water treatment plants, distribution pump and pipelines, installation of 58 flow meter in water treatment plant and pipelines. We have SCADA production and distribution. We have smart pumping station. We have automatic meter reading for potential customers. And thank you. I think it's the end of my presentation.
Okay, thank you. If we've got any questions, if you'd put them in the chat for us. Just have a look on somewhere. So it's just, I've got a couple here. First one is, how do you deal with data accuracy issues you receive from the DAS contracts? You're on mute again. Sorry, Palupi, you're muted.
Yeah. Yeah, okay. Okay, thank you, David. About accuracy data, we incorporate service level agreement. We have agreement with vendors, like the deviation should be more or less 3% from the comparative analysis and once in a month. Yeah, and we have agreement about the data frequency that we receive in a month is about 92% of total number of data that should be transmitted to us.
Yeah.
We receive data in every 5 minutes.
Yeah. Very good. And then the next one, so how did the management of Surya Sembada utilize the digital data to make effective decision making?
Okay. All of directors here has a monitor in their own room to see the dashboard of the digital data. The application has work order feature, so the management can monitor and control what happened in the field and how the staff responds to the problem. And all the data also be used to analyze the system and to design business plan and budget.
Right, and then there's just another couple here in the chat I'll just read out. So the first one's from Rin, which is, what devices do you use for monitoring pressure, and are they part of the DAS?
We use a lot of devices. Probably I can go back to the presentation. We install 434 pressure sensor in water treatment plant, distribution pump, and pipelines. And we also have 58 flow meters in water treatment plants and pipelines.
Yeah, and then those are under the DAS contract. There's another question which ties in with this, is from Evan, which is, data accuracy is core to a solution like this. So how do you manage the fleet of sensors that this solution relies upon? I think you did touch on this earlier with KPIs and the DAS and calibration and things, but if there's any more you can add to Evan's question, it would be good.
Sorry, David, can you repeat the question?
Yeah, it's just how do you manage the fleet of sensors that this solution relies upon? So I think you do it through the DAS contracts you were talking earlier.
Oh, okay. We don't operate and maintain the sensors, because operation and maintenance is the responsibility by the vendors. But we do calibration once in a month. We have sensor for control to compare the performance of the sensor from the vendor compared to the sensors we have in Surya Sembada, and the deviation should be no more than 3% when we comparing the data from two gadget. Yeah.
Okay, brilliant. And there's a couple of questions here in the chat. I don't know if people have seen the answers already, but I'll just read them out and hand it over to Arvin and Evan just to answer them verbally, so if they can come back on the lines. The first one's from Juan, which is, how do you ensure that the network is represented accurately when it changes, GS layers, updates, etc., etc.? So I'll just hand that over to Evan for his answer first, because he's the first one back on the line.
No, fair enough. I think Arvin's put a comment on there as well. I mean, effectively, you need a change management process that the WardCorp have set up. Effectively, it's an update of the underlying hydraulic model to reflect what's going on, if there's any changes in the network. And my plug would be, when you're changing models that underlie these things, you want a human to be involved, because real-time control, you want to make sure something automatically doesn't go in there that might affect the outcomes of real-time control. So, this system, in process, you have somebody involved to engineer to make sure those changes are accurate and reflect the network.
Yeah.
Yep. Similar to what Evan was saying, change management was key. And earlier on in this journey, we identified the business processes we have to put in play to make sure not people are just bringing stuff online or taking stuff offline. Now, as a minimum, if the system detects a major anomaly, we've got safeguards to make sure it doesn't operate under these conditions. But ultimately, if there's anything that we're changing to the entire pipeline, we make sure there's a human person actually saying, "Yep, add this, do that, validate, then run."
And then there's another question here from Kenta, I think I've said that right. Was there any security risks in making such a vital pipeline more automated? Is it a risk of internal or external threats?
So yes, the risks are there. I can't obviously discuss what those risks are, what those mitigations are, but what helped us was we undertook major hands-on activities. We got third-party facilitators in. They asked the hard questions: what would happen if this goes wrong? What would happen if this goes wrong? What happens if this person does that, and all that? So we discovered what our risk profile looked like, and we took steps to mitigate them. So every utility will have their own risk profile, and it's best to discover that during the hazard process and spend the time to say, right, what dismantle the system, if you like, and really go through it.
Yeah, as always, sorry, David, every utility's got a different setup, a different appetite, and some are on-prem, some are in the cloud, and it's always a conversation you carefully work through and cover off all the specific risks.
And another one for you too, which is how did you deal with low data quality, and how do you improve them to be used in the machine learning models?
So I think earlier on, we said we had the best data until we started to unpack what was the best data looking like. Yeah, we had some pressures in PSI, some in VAR, and we were like, okay, guys, maybe we should standardize everything. So earlier on, we had to look at the entire pipeline and see what we are dealing with, right? And we knew we had low quality data. We said, okay, this is what, as a minimum, SUEZ would need to make it run effectively. And then we, in Watercare, we went on and we cleared up all those legacy data. So we standardized them and all that. And we put in systems to make sure in the future, anything that's coming through must meet this minimum data quality. If not, we'll just reject that data outright. So, yeah.
Brilliant. And just one final question here for Palupi. You two get off easy now. So it's from Rin. It's just curious if you have started to implement digital water meters in some of your networks.
Pardon, David?
The question is just curious if you have started to implement digital water meters in some of your networks. I think it's probably referring to smart meters on customers. You've talked already, the big ones would be digital on the network.
Okay, thank you, David. Actually, we had a mandate from mayors to improve our service, to have high pressure throughout the city at 2 meters at minimum. So we do a lot of investment to replace the pipes and build the reservoirs. But we have to have a picture of the performance of our distribution system. So we have to install the pressure and flow monitoring throughout the city to analyze, evaluate that our investment is good, and also to make the response quicker when there's a problem in a distribution system, like there's a leakage, so the pressure drops, and then directly the system generate the work order for the technical staff in a field, and the technical staff go to the field and fix everything there. We stated to our customers that we have a quicker response from 3 days. Just go to 1 day. So 20 hours after complaint, we have to solve all the problems in the field. That's why we need that IoT system or real-time flow and pressure reading from the distribution system.
Thank you very much there. So I'll just like to say thank you to our 3 presenters. Big thanks from me. It's been very interesting and enlightening. And I'll just hand you back to Zolbu.
Yep, sounds good. Thanks everyone for joining, and really appreciate all the support and all the knowledge bringing into us. Evan, Arvin, Palupi, really appreciate your time. And Dave and Asem, also thanks to you for leading a great APAC Digital Twin Working Group. So we've been very excited to bring this webinar to you all. So thank you all. Please share your feedback in the link that I've mentioned. And also say hi to me if you want to send me an email, or let's connect on LinkedIn. So I hope to see you all in person or in our next Scholar webinar. So bye for now. Thanks, everyone. Have a great
Thanks all.
rest of
Good
your
night.
day. Yeah,
Bye.
take care. Bye.